Hello everyone, this is me, Ibrahim Abdussalam. Today I will talk about Siemens Global analog input. Logo can accept up to 8 analog signals. The voltage level for the analog signal range from 0 to 10 volt in case of voltage signal. In case of current signal, the range must be selected between 0 to 20 milliamp or range from 4 milliamp to 20 milliamp. Also, the analog logo can accept BT100 temperature sensor. In Siemens logo, you can have analog output or analog input. In case of analog output, the value or ranges can be selected from this menu from input setting, I/O settings. The ranges can be selected from this menu. And the analog output, the user had to have extension analog output module. In case of analog input, there is two options. The user can use the onboard 4 analog input signals or have extension analog input module. In case of using onboard logo analog signals, we have three choices. Enable 0 analog input, so all the digital input or all the input terminals are operate as digital terminal or digital input. Enable 2 analog inputs. The input terminal I7 and I8 will convert it to will operate as analog input and will be called as analog input 1 and analog input. If the user select enable 4 analog inputs, so the input terminal I7 and I8 will be for analog input 1 and analog input 2, and in addition the input terminal I1 and I2 will be analog input 3 and analog input 4. We have some blocks help in our programming. First is analog comparator. We can use it to compare between two signals and get on off based on the difference. For example, AX and AY. If AX are greater than AY, the output will become high, as can be clear from this figure. And at this point, AY greater than AX, the output will become 0. This is the analog comparator. Analog threshold trigger. It it have a digital output based on and off value or preset value. Okay, let's go to our exercise. Assume that liquid in an industrial plant has to be kept at specific temperature between 40 and 45 degrees by using a heater and cooler. The system uses BT100 to measure the temperature. If the temperature is below 40, the heater turns it on until the temperature reaches 40. If the temperature is higher than 45, the cooler will turn it on until it reduces to 41. Write a PLC program and draw the circuit connection. First, we need to enable two analog inputs from properties. I/O setting. Enable two analog inputs. Okay. Now we need to drag and drop an analog input. We will need two thresholders, one to turn on the heater and the other for the cooler. First, second, and we have two outputs, the cooler, the heater, and the cooler. Just simply connect everything. Okay, double click here, command heater. Heater. Cooler. Double click here from the thresholder. The sensor will be BT100. The unit Celsius resolution instead of 0.1, I don't need fraction, so I will use direct. Okay, I want to turn on the heater if the temperature is below 40. So the heater okay, make it 0 from 0 to 40. So the heater will turn it on from 0 to 40. Okay, and the cooler I need to modify it. It will be BT100 Celsius 0.1. From 40 I need to turn on 45 until from 45 I will turn on the cooler and I turn it off at 41. Okay, let's simulate this program. And the temperature starts at 50, which is not logic in this application. Okay, the temperature now 3, 4, 5. The heater was on until the temperature reached 42. Okay, the temperature now 51. The cooler is on. It will keep on until the temperature become 41. The cooler is off, and so on. Let's go to the next part. Display the liquid temperature on as a message text and add a bar graph in second line. In the fourth and fifth line, write the status of the heater and cooler. Okay, so we need a display text from miscellaneous. I will enable the screen forever. So I will give it not here, double click. I'll write temp equal analog. I will add the analog value. Then I'll give it a unit, Celsius. I will have a bar graph down, vertical, horizontal, and it ranges from 0 to 50. So I'll give it to, let's say, from 0 to 100, and give it 9, 10 cells. Okay. Okay, I had to specify and fix. Okay. The second part will write the state of the heater and cooler, fourth and fifth line. Okay. Heater, cooler, on off, output Q1, and here on off, output Q2. Okay, let's simulate this part. Okay, the cooler is on and the heater is off and the temperature is 55. Okay, I will reduce the temperature. Cooler now at 40, the cooler is off and the heater is off. Now 39 until I reach 40 again. Then okay, let's continue our program. If the temperature exceeds 50, turn on an alarm and the display background turn to red to indicate the alarm. Okay, so we need another folder here. And the alarm will turn it on at 50 and turn it off at 50 also. This will activate our alarm. Okay, also we need to have a memory to turn on the screen to red. Also we have memory flag here. Memory and one red background. And red background, so everything comes red. Okay, let's simulate this program. The temperature, the cooler is on, the alarm is on, and the background comes red. Okay, thank you for watching and bye bye.